So instead of just talking about this code, let's actually run it. So as before, I have two windows open up here. One is my C Spark Scala folder, where I'm going to be keeping all the materials and projects for the course as we go. And then I have my Download Spark Scala folder here, which is where I downloaded all of the course materials to. So let's go to the 1800.csv file here. That is my actual weather data. That's real weather data from the year 1800 in a couple of cities in Europe. And you can click on that and kind of preview the contents. It's what I described earlier. You have a weather station identifier, a date, what kind of data it is, which might be Tmax, Tmin, or precipitation, and the actual temperatures in the case of Tmax and Tmin are represented as tenths of a degree centigrade. So let's go ahead and copy that and paste it into where I'm working from. All right. Now let's open up the Scala IDE. Again, make sure the workspace is set to where you just pasted that file into and where your other projects are. All right, now let's open up the project and the source folder and click on the package, com.sundogsoftware.spark. Right click on it and say import. Go to General File System, hit Next, and browse to where we downloaded the course materials, as usual. For me, that's under Downloads and Spark Scala. We're going to select the min temperatures.scala file here and hit Finish. And we can open up the package now and take a look at it. All right, let's close all the others at this point. Don't want things to get too messy. So this is the same code we talked about in the previous lecture. Let's take another look at it because it makes more sense when you see it all together sometimes. As usual, we start with the package name that we're going to be under and we import the things we need. You'll see we're actually importing this min function here as well as the usual suspects. We're going to create a min temperatures object that contains our Spark driver script. We have our main function where everything happens, and we also created a function called parseLine that does exactly what it says. It parses a line of raw input data from that 1800.csv file and transforms it into a tuple of station ID, entry type, and temperature. Station ID being where the weather measurement was taken, entry type being one of Tmin, Tmax, or precip, and in the case of Tmin or Tmax, we will extract a temperature field in Fahrenheit. And all this code does is split it up based on commas, extracts the station ID from the first field, the entry type from the third field, and the temperature from the fourth field, and then it converts that temperature while it's at it from tenths of a degree centigrade to Fahrenheit. All right, so let's dive in here. Set the log level to error so we don't get a bunch of log spams. Create our Spark context that runs on our local machine using every CPU core. We're going to name it min temperatures. All right, first things first, load up our actual raw data file, 1800.csv, into a lines RDD. Then we're going to map it using our parseLine function that will convert that into more structured data. That is a tuple on each line of station ID, entry type, and temperature. Next what we're going to do is filter out anything that's not a minimum temperature, because again, our goal here is to find the minimum temperature across an entire year of data for each given station ID. So we're going to pass in this filter function that takes in a given line, looks at the second field, which is the entry type again. If it's equal to Tmin, then it lives. If it's not equal to Tmin, it dies. So we end up with a min temps RDD that contains only Tmin entries. Next thing we do is strip out that middle entry type field because it's no longer meaningful. Everything in here is a Tmin, so why would we carry that Tmin data around everywhere? Again, you want to strip out all the data you can to minimize the amount of data that needs to be pushed around during a shuffle operation. So that's what this map function does. It just takes that tuple of 3 values and converts it to a tuple of 2 values. And guess what? That makes it a key value RDD, where the key is now the station ID and the value is the minimum temperature seen for every day in a given year. Okay, so at this point we have a station temps key value RDD that has keys of station IDs in string format and values of minimum temperatures seen for every day of the year for that station. Finally, we'll call reduce by key to find the minimum temperature for each station ID. So what this does is it takes that station temps key value RDD, looks at every minimum temperature reported for every day of the year for each station, and preserves the minimum found overall for that station. So as two different values, two different temperatures are compared to each other, we just take the minimum of the two. So what we end up with is the answer we want, this min temps by station RDD, which is just going to be keys of station IDs followed by the minimum temperature seen across the entire year for that station. We then collect the results, sort it, extract them, format them the way we want, and print them out. So let's go see if it actually runs. Go to the Run menu, create Run configuration, double-click Scala application, and we're going to name this min temperatures. And the main class is com.sundogsoftware.spark.minTemperatures. Let me double check that's the correct object name. I can't actually scroll up there, but I believe it is. Let's hit run and find out if it works. Well, it's doing something. Hey, there we have it. It works. So for this station ID, the minimum temperature reported was 7 degrees Fahrenheit, 7.7 to be precise. And for this other station ID, the minimum temperature found in the year 1800 was 5.36 degrees Fahrenheit. Now, as I said, this is Paris and Prague, as I recall, so they would be pretty similar. They're not that far apart, so that makes sense. That kind of passes our sanity check. And you should always, do that with your end results to make sure there's not a potential bug that you could have caught. All right, so that's our example of using filter and another example of using key value RDDs. Now, at this point in the course, I think you're about ready to actually start writing some code of your own, maybe start fiddling with this a little bit. So that's my challenge to you right now. What if you were to modify this script to instead find the maximum temperature found for a given station ID throughout the year? What changes would you make? Why don't you hit pause and go try that out? So remember, instead of tmin, we're going to be looking for tmax entries. And instead of trying to preserve the minimum temperature found, we'll be preserving the maximum temperatures found. So hit pause, go take a crack at that. Make sure you also look for, things where we're talking about minimum temperatures and change it to say maximum temperatures, things like that. But, a very simple way to get your feet wet with some Spark development. So give that a try. Hit pause, and when you're ready, we'll come back and take a look at how I did it. Ready? Okay, let's move on. So we're going to go back to the package here and right-click on it and import the max temperatures.scala from where we downloaded everything. Again, for me, that's under Downloads. Open up. Spark Scala. Max temperatures.scala. And we'll import that in. Let's double click on that. Take a look at what I did. Nothing too crazy here. All I did was change all the object name from min temperature to max temperature. The parsing works exactly the same way, but we're naming this thing max temperatures now, and now we are filtering out things that are not just tmin, but only things that are tmax. The other relevant change is instead of calling min here in our reduce by key operation, we're calling max to find the maximum temperature throughout the entire year for each station. And again, I just changed the wording here to reflect the results that we want. So let's go ahead and run that and see if it works. Compare that to what you've done, and hopefully you did about the same thing and got the same results. But if you want to check for sure, let's see if your end results are the same as mine. So let's go to run configurations, and we're going to create a new one called max temperatures. Class here is going to be com.sundogsoftware.spark.maxtemperatures, and we'll run that. And in this case, we end up with an answer of 90.14 degrees for both stations. And seems a little bit coincidental, but I checked that really is the correct result. So if you ended up with an answer of 90.14 for your code of finding the maximum temperature for each weather station in the year 1800, then you did it right. Congratulations. Good job. We'll do more and more hands-on stuff as we get through the course, but there you have it for now. You might ask yourself, why are there only 2 weather stations in here? Well, there wasn't a whole lot of good record keeping in the year 1800, it turns out. If you get data from later years, there'll be more and more information into it. So if you do want to track that data down and play with bigger data sets, feel free to do so. But otherwise, there you have it. Some practice filtering and dealing with key value RDDs yet again with real weather data. Woohoo! So if you'd like to challenge yourself, here's an idea. Go back and modify this code to actually figure out what day had the most precipitation for each location that we have precipitation data for. And the general concept will be the same for the code. You're just going to parse out the data a little bit differently and treat it a little bit differently, right? So have at it. See if you can figure out what day had the most precipitation in the 1800.csv data file that we have. Give that a shot, and I'll see you in the next lecture.